Good evening, cool cats and great chemists, Red Devil chemists. This is Coach Scott. Let's talk about electron configurations, right? So the electronic configuration, it shows the distribution of all electrons. I'm going to put this in the full screen in an atom. So there's three components to the electron configuration. There's a number like that. That number shows the shell or the energy level. Then there's a letter like that. That denotes the type of subshell, either S, P, D, or F. Then I have a superscript number that tells me the number of electrons in those orbitals. I don't know if I can get it to move on. So these are the orbital filling diagrams of the first, 13 elements. And these are those configurations. And you can see there's only one electron for hydrogen in the 1s orbital. So I just write the configuration 1s1. Now, let's look at sodium. It's number 13. So I've got 2 electrons in the 1s, 2 electrons in the 2s, 6 electrons in the 2p, and 1 electron in the 3s. So I'll write my configuration like 1s2, 2s2, 3p6, 3s1. Not very hard. So this is the ground state configuration for sodium. 1s2, 2s2, 2p6, 3s1. Now if you look at every one of those superscripts and you add them up, that's 2 plus 2, that's 4, plus 6, that's 10, that's 11. That's going to give me the atomic number, or the number of electrons in a neutral atom. All right? So you do need to know how many electrons you've got in order to do an electron configuration. Let's look at Krypton, element number 36. Now this is sort of cool in that I go from 2p6, 3s2, 3p, but I don't go to 3d. I got to go to the next lower energy level, which would be there, the next higher, which would be the 4s subshell. So I go 3p6, 4s2, 3d10. All right. So you got to be careful with that. It is sort of a faux pas if you do it 3s2, 3p6, 3d10. So let's practice a little bit. Let's do phosphorus. Phosphorus atomic number is 15. 15. Let's do the orbital diagram. 2, 4, 6, 8, 9, 10. All right, 11, 12, 13, 14, 15. So all I've got to do is write the energy level with the subshell type and the number of electrons. So I've got 1s2, 2s2, going right there, 2p6, 3s2, and 3p3. There, we are done with that. Calcium, element number 20. Element number 20. Let's do the diagram. 1, 2, 3, 4. Of course, that's the number of electrons. There's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Let's write it out. 1s2. I've got 2s. That's got 2. I've got 2p6. I've got 3s2, 3p6. Whoops. And then, of course, 4s2. I add all those up, and they should equal 20, and they do. Titanium, element number 22. I look, that's why I know it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which rule did I violate? Think about that one. All right, so that's 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. 22, so 1, 2. I've got 22 electrons. I've got 1s2, 2s2, 2p6, 3s2, 3p6, and then of course 4s2, and let's finish up with 3d10. Again, I've got to get that lower energy 4s2 before I go into the higher energy 3d. Let's finish up with bromine. Bromine is element number 35. Element number 35. Whew, this is going to be a while. Bromine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 35. 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. That makes sense. So I got 5 more to go. 1, 32, 33, 34, and 35. So I've got 1 open spot left. So let's write our configuration out. 1s2, 2, 2s2, 2p6. I'm just moving up the line. 3s2, 3p6, 4s2, 3d10. Boy, I wish there was a shorthand way of doing this. This can take a long time. That might be a little foreshadowing. So which of these is the electron configuration for lithium? Lithium is atomic number 3. So I've got to fill up my 2 first. So of course that's going to be what? C. Not hard. Which of these is the electron configuration for potassium? Potassium is element number 19. Well, let's see. I should have an odd number on the end. So let's count. 2, 4, 10, 12, 18, 19. That's our 1. Which is the atomic number of a neutral atom which has the electron configuration below? Well, we can add them all up. 2, 4, 6, 10, 12, 13. That's aluminum. Which neutral element has the following electron configuration? Let's start counting up. 2, 4, 10, 12, 18, 20, 20 and 30, 33. Element number 33 is arsenic. Arsenic and old lace. Yeah, I don't know anything about that. A neutral atom with the electron configuration shown below gains an electron. A neutral atom. What is its new ground state configuration? So it's adding an electron. If it adds an electron, the S2 is filled up, the 2s2 is filled up, 2p6 is filled up, so it's going to have to go to as an electron, to that state right there, because there's no other spot for it. So it has to go to the 3s1. Can't go 2p7. It can't go to the s. Can't have 3 in the s. So that's where it's got to go. All right, moving on. Now, those are the neutral state. Now, we've looked at some of these excited electrons where they've jumped orbitals and they're at an excited state. How do we account for those? All right. So you're not going to see this often, but understand it. So I've got a sodium vapor lamp electrons, and they're excited to the 3p level by an electrical discharge, and of course they emit a yellow light as they fall back down to the ground state. So sodium is element number 11. So I should have a total of 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. but it's not at the 3s now, because remember, this is in an excited state and it jumped up to the next higher energy level. It could be at the 3D level or the 4P or the 5F. It could be up higher. It just depends on what's going on. Which of the following would be the correct electron configuration for a magnesium ion? 2 plus. What this means, we haven't got into ions yet. I'll just tell you real quick. So magnesium is element number 12. That means it's got 2 more protons than electrons. All right. It's not neutral, so there's 12, always going to be 12 protons, so that means there's 10 electrons. So we look to where we have 10, 2, 4. Well, that's not right. We know that's not right because we don't go 1s, 2s, 3s. 1s, 2s, 2p, that could be 1s, 2s, 2, 2p6, 2, 4, 6, 10, 12. Well, that's magnesium. I don't have enough. That has to be C. And it is. Which of the following would be the correct electron configuration for a chlorine 1 minus ion? So chlorine is 17. What the negative means is that it added an electron. All right. So instead of 17, it now has 18. So if we look at this, it's going to be 2, 4, 10, 12, 18. Everything's in order. That would have to be A. Which of the following represents an excited state electron configuration for sodium in A? Of course, that's sodium is number 11. So this you got to think about. 1s2, 2s2, 2p6, 3s1. That's the ground state configuration. That's what it normally is. Can't have 1 extra in the P7. There's only can have 6. But let's look at this. 2, 4, 10, 11. But now it's jumped to the 3p subshell. So it could be C. Which of the following represents an excited state electron configuration for magnesium? Of course, magnesium is 12. So the ground state would be 12 total in the electron configuration. So that would be 2, 4, 6, 10, 12. That's the normal configuration. Can't put 7 in a p orbital. Can't do it. Subshell. But if I look here, one of those electrons from the 3s level jumped up to the 3p. That would be C. So guys, that's atomic structure. And we're going to learn more about these ions, not the next unit, but the unit after, and what's going on with these electrons, gaining, losing. But this is a lot to learn, and I guarantee most of y'all have not had this, but I know you're going to be very successful. Why? Because you are Red Devil scientists. So guys, Coach Scott saying have a good evening and deuces.